Hello, this is my 4-bar linkage progress. It's a continuation of the proposal. As a short review from last time, my problem statement has changed. Before, I wanted to generate a 4-bar linkage that will closely match the inputted trajectory or path that the user would provide. Now, the problem is to generate a 4-bar linkage that moves with a constant velocity. The reason we care about this is that many machines operate on a high life cycle and therefore need to be reliable for a long period of time. High accelerations can cause bending of the structures or even grinding of gear teeth, which would reduce the overall lifetime of the machines. And so the main thing that I'm minimizing is acceleration. And the givens will be that the driven point has a constant velocity, and we assume this to be a motor that is driving this point. So far for progress, I have been able to generate a code that would determine the position of the 4-bar linkage, as you can see on the left-hand side. It also has an accompanying animation which I was not able to capture, but this is the end state with all the points drawn at each time step. On the right-hand side is a continuation of my prior goal. Now that I am looking to optimize the speed, here are my speed and velocity plots. We will cover why these are not optimized in the next slide. Issues with optimization. The reason why I was not able to provide an optimized 4-bar linkage with a constant velocity was because I was unsuccessful in finding any optimization function examples that could be easily applied to this problem. What I'm running into is that there are too many unknowns and not enough equations to work with. The unknowns are the lengths of the linkages, the degrees at which they're moving, and then also like the other velocities besides the one I am trying to minimize, either the velocity at 0.3 or 0.4 specifically. And one thing that I've run into is applying the nonlinear constraints. We would create a additional function just like the example would. The problem is that I would need to add additional inputs to that function in order to run it properly. And because I am running it through a for loop and constantly updating the lengths and degrees at each time step, that becomes harder to do. And for additional constraints, which I have not worked with yet, Grashoff's law, this is to ensure that the driven linkage can rotate in 360 degrees, making sure the angles don't go beyond what is feasible. The lengths are non-negative. There's no such thing as negative space in our physical world. And the closed loop linkage equation, which is just to make sure that it is bounded in some way. And those are my current issues. In terms of solutions, I am open to ideas, but I'm still currently investigating possible ways to solve this problem.